Good morning. Wow, that was remarkably fast. Usually I have many more good mornings. So welcome to the first full day of the conference. Our opening speaker will be Paul Romer, who I will introduce in just a moment. But before I do, I wanted to, we added some new technology to the conference this year, since this is a tech policy conference, and we'll see if it works. We want to try to make it a little bit more interactive. So I want to introduce this system before we start so that you all can use it. We're using this system called Slido to facilitate questions. You can submit questions using it at any point during the panel. Everybody will see the questions that are submitted, although Wallace will be moderating them, so don't just start swearing, or you can, but it won't go up there. And you can upvote or downvote questions as it goes. And the speakers might address them as it comes, but we'll turn to them at the end, so we'll already have some questions. So just as a practice, supposedly this helps get it going. This is how to use it. If you have your phone, and I know you all do, because nobody's ever without it, and you don't want to miss Netflix, if you go to slido.com, slido.com, on your phones, or you can do it on your computer too. It'll ask you to enter a code, and the code is TPI Aspen. Case doesn't matter. And we're going to start off with just a little poll so you can see how it works. I don't know how many polls we'll do, but you should see on your screen polls and questions. And just answer them. Which of the following of these do you think are the most important tech issues of 2018? And you can vote. I don't know if it's going to show you the results or if we have to go to those later, in which case we might show you them later or not. I don't know. And the other thing you can do to submit questions, if you just click on questions and type your question, it'll just show up wherever it is. So, yeah, TPI Aspen. So Wallace, maybe you can switch to the question page too. Can you switch to the question page, Wallace? Can you switch to the question page? Oh, you're doing it, okay, yeah. Oh, you have to review them. And you're moderating them, Wallace? Okay. All right, so basically that's it. And they should come up and you can upvote them and downvote them and so on. So we'll see how it works. Hopefully this will add another dimension to it. Okay, now, moving on with that. So we are truly honored to have Professor Paul Romer here to kick off the forum. Paul is an economist and policy entrepreneur, university professor at NYU and director of the Marin Institute of Urban Management. He's also the founding director of the Urbanization Project at the Stern School of Business, which tries to harness the rapid growth of cities in developing countries to create economic opportunity and systemic social reform. He was also recently the chief economist at the World Bank. Before coming to NYU, Paul taught at Stanford University's Graduate School of Business, where he was also served on my dissertation committee. That part wasn't on your official bio. I was really surprised. While there, he took an entrepreneurial detour to start Applia, an education technology company dedicated to increasing student effort and classroom engagement. To date, students have submitted over, it said on the website this morning, 2 billion answers to homework problems on their site. And he's also primarily responsible for what is known as endogenous growth theory. It's key insights where the technological progress doesn't simply happen, but that it derives from investments in human capital, investments in research. And importantly, because the benefits are not don't attribute are not just private, they turn around and make all capital, human and otherwise, more productive. I think that's a pretty concise definition. And if that sounds obvious to you, it's only because Paul made it so over the past 30 years. Before he formalized it, growth models basically assumed that technological progress would just happen as long as a country invested in physical capital. And those models determined lots and lots of policies aimed at promoting growth here and in developing countries, and those old models turned out to be basically wrong. So with that, I'm going to hand it over to Paul, who is going to talk to us about the code, copy, decode cycle.
Well, it's a pleasure to be here and also to see a few old friends like Roger, and I saw Hal at some point. So we'll try to keep it from deteriorating into sort of inside baseball amongst the economists. I grew up in Colorado. I didn't ski in Aspen. My father owned a ski area called Geneva Basin, which they sold and has since gone bankrupt. It was between Grant and Georgetown, if you're from this area. I can remember vividly a point in time where his partner in that ski area, who's somebody who didn't graduate from high school, was cutting a roll of carpet to lay down. This is during the summer for the ski lodge. And he took his tape measure and then measured a version of a 3, 4, 5 triangle to get a right angle to then cut the carpet. And I was so impressed because it never occurred to me that the Pythagorean theorem actually had some practical value, like it with a tape measure. Or actually, anything I was learning in school had any practical value. But with just a tape measure, you can construct a right angle. It's the accumulation of insights like the Pythagorean theorem that lies behind this process of growth that Scott was just describing. And what I want to do today is dig into our understanding of those insights. This will verge on useless big think, but occasionally it'll touch, I think, concerns that might be of interest to you. One of the things I've already, in my updated title, changed it, I think, from code, copy, decode to code, publish, decode. And let me show you what I mean by that. We have something that economists refer to, and it's become pretty widely used as a term, human capital. So this person, Walt, had some human capital. He knew how to create a right angle. Now, if you want to have growth that matters for the whole world, what's got to happen is stuff in neurons. Human capital is stored in neurons. Stuff in neurons has got to get codified somehow into something I'll just call C, codified code, whatever. Then once it's codified, so let's call this the publish stage, because it's more than just copying. So this is code, publish, and then there's the decode process. So some other person looks at some codified representation of the information and then reinstantiates it in neurons, so that person can also go out and make right angles. A lot of attention gets placed on this publish stage. There's a lot of stuff that we can see and that goes on once things are codified. So think about printing with movable type. This is a big change in publication. Or think of the internet and search. So it's very tempting to focus most of our attention, and I think in my own work, I've tended to focus most of my attention on this publishing process, where it's already codified, you get extra copies, you make them available to people. The point I want to make today is the coding step is very important because it influences the decoding step, and that more effort to lend clarity and precision to coding could have enormous efficiency advantages. One of the interesting features about this idea of publishing or sharing codified knowledge is that it has this enormous scale effect. that if you can convey some codified knowledge to one person, it might have value V. If you can convey it to 1 billion people, it has value 1 billion times V. And we're really in a world now where you can convey things to, what will end up being 10 billion people on Earth. This is the ultimate source of the gains from trade, the gains from globalization, the gains from interaction. It's the sharing amongst large numbers of people of things that don't have to get rediscovered. You don't have to reinvent the wheel. So these scale effects are, I think, what's driving globalization. By the way, there's conventional stories about, well, they have sheep and we have, wine because they live in a sunny climate, we don't. But, that maybe gets you up to gains from trade at the scale of, like North and South America. But, why do you want to go from there to 1 billion or 10 billion? I mean, you got all the geography you need, you got all the people. There's something else which is going on that makes it worth having a global economy. And it's the sharing of an insight discovered anywhere in the world with everybody who can take advantage of it, which is fundamentally behind that. But so that's a kind of an understood part of this dynamic of ideas. It doesn't just drive growth over time, it drives growth that's been speeding up because we've got more and more people better and better connected with better publishing facilities. So ideas are being developed and shared more rapidly. But there's another implication of this that I started to emphasize just internally in organizations, which was something like this. If there are 100 people who are going to read something you write, you should spend 100 minutes to make it take 1 fewer minute for everybody to read your document. If you're trying to be efficient about the use of time, that scaling effect, and if it's 1,000 people or 10,000 people, the obligation for efficient communication, the obligation to invest more and more in the coding stage becomes enormous because there are a lot of different people who are going to do the decoding, and better coded information can be more readily decoded. So that's really the theme I want to try and drive home today. Now, to be clear about this, think about coding up the way to cut a carpet at a right angle. Today you could think of just taking a YouTube video, and if people paid enough attention or if you zoomed in on the tape measure, they might kind of get the point about a 3, 4, 5 triangle. You might use words and tell them, okay, do this, measure out these arcs and so forth. But if you code up this information in the form of mathematics as well as in words, you can convey it much more clearly. So if you've got a triangle with sides A, B, C, then we know that if A squared plus B squared equals C squared, then you've got a right triangle. And you can check that a 3, 4, 5 triangle makes that work. If your carpet is 10 feet wide and you want to measure at a point on the other side of this roll of carpet, what you can do is instead of using, say, the 4 dimension on the cut across, you can just use 2.5 times 4 to get 10. You just take 2.5 times the 3 and the 5 as well, so 7.5 and 12.5. And the math lets you check, oh yeah, if we multiply each of A, B, and C by 2.5, the thing still works. So the math can distill key points, can suggest generalizations, can convey insights very effectively. So math is a domain-specific language that we use alongside of words, and they together can lead to more efficient communication. The point I'm going to come back to is that math can also be used to obfuscate and to exclude. You can just throw up all kinds of barriers to entry so nobody can understand what you're saying, and then you can say in words, and presto, changeo, I'm a genius, here's what this all means, and nobody can check it because they can't follow your math. So you want to think of these additional codification systems as, at best, double-edged swords. Let me now shift to an example where we're talking about words and code, literal code. There are people who know how to make secure, relatively secure applications. There's a lot of developers who are not specialized in all the details. And one of the things that we've observed is that lots of actual applications that get built don't reflect the knowledge that the experts have about how to keep applications secure. So why is it that we're not sharing this stuff which is known? This was a paper that was the result of an empirical exercise where they tested the hypothesis: if the API which a developer uses to access the cryptographic library is restricted and simplified, will that solve this problem? And it does have some benefits. You can avoid bad choices that an unrestricted protocol might allow, but here's the takeaway. And for you over here, I'll read it. For 20% of the functionally correct tasks, like they generated keys, they encrypted a message, participants believed their code was secure when it was not. So even with these simplified protocols that reduced some of the obvious mistakes, people were still getting it wrong. These were experienced Python developers, about 250 who participated. So the conclusion that they come to is that you need more than just the code. It isn't just a better API, better code. You have to have documentation that explains to the users what's going on in a clear and precise way, and in a way which they can readily absorb. And without that documentation, you're going to continue to have this failure of the reuse of the knowledge about how to produce a secure application. So we use words and code, we use words and math, sometimes we use all three, but we often don't insist that the words be clear enough, or the words and the math and the code together be clear enough in communicating a message. Now, there are some people who think they know the rules for clarity in writing. I don't think anybody knows the rules for writing. So what do we do? I mean, why is it that the documentation is so bad for these cryptographic protocols? I asked a student once, what's the difference between ignorance and apathy? The student said, I don't know and I don't care. So part of the problem is that people who write the documentation often don't care. They don't have any incentive. Although, why did they write the code? Why did they try to come up with a better API if they didn't care? Often the problem is that they're ignorant. They don't know whether people are actually understanding things. And it's a chronic problem as somebody doing the coding, is you can't put yourself in the shoes of somebody who doesn't already know this stuff, because you already know it. Part of what I liked about this paper was it showed that you can do empirical work. You can find out empirically if you think your code, if you think your words actually conveyed something, go out and see if people understood what it was that you were trying to convey. So even though we don't have a model or a theory about clear communication, we can test and see if it's clear, and we should be doing much more of that and using the results to tighten up, to amplify the incentives for clear communication. I'll come back to this example at the end, because I have a little more to say about it. So let me turn to Unicode and just give you a specific example of something where I think there was a real failure to explain clearly. This is something I had to sort out recently because I was trying to add a goddamn apostrophe to a web page. Hours lost over the damn apostrophe. So Unicode has what I think we should call characters. For reasons I'll get into in a second, people don't call them characters. Here's a table of characters. Some of them are the familiar ones, like the Latin letters. The lowercase a, if I can blow it up here, has a sequence number. It's number 61. So we got characters and we got sequence numbers. Now, you have to be clear that the lowercase Latin a is not the same as the glyphs. We know they're different fonts that have different shapes that convey this letter A, but there's an abstract notion of the letter A, and it's character 61 in Unicode. Now, I'm using character a little bit, expansively, because there are these cool characters, so to speak. My favorite one is bell, B-E-L, right here. Bell used to ring a bell when that one came over the wire. There's some other ones that are a little more familiar, like line feed and carriage return. Why we have two, I don't know. But so it's a little bit of an abuse of the language to say these are all characters, but close enough for macroeconomics, as we say. Okay, so where's my apostrophe? Let me jump past the apostrophe, which is right here, because you might look at the apostrophe. Actually, no, where was my apostrophe? It's this one. I didn't want to show you apostrophe because you could look at that and say, oh yeah, it's number 2, it's 2019. That's cool. But let's look at then quotes, curly quotes. Oh, that's number 21C. It's like, oh hell. What kind of a number is 21C? Okay, it must be hexadecimal, which is like, why do I have to think in terms of hexadecimal? And moreover, when they talk about this, they don't refer to this as the sequence number, they refer to this as the code point. So this isn't a character, this is a code point, and I don't know if the apostrophe is the code point or if 21C is the code point. And either way, what the hell is a code point? And why aren't we just talking about characters and sequence numbers? The whole point about Unicode, the brilliance of Unicode, was that they just took every character in the world and some sort of characters like bell and non-breaking space and so forth, put them in a sequence, gave them all numbers, and then if you're a developer, it's like refer, when you want an apostrophe, just refer to number 21C, and you don't have to think about how it's coded in terms of bits. You can completely ignore the encoding. Okay, that's cool, I get that, but then why are you talking to me in hexadecimal? Why don't you just tell me that this is, I think, those of you who can do this in your head, you can check me, but I think this is 80-20. The apostrophe is actually just number 80-20. We can convert hexadecimal into a decimal number. The problem with using hexadecimal in all these tables is it kind of sort of suggests something about the binary representation in terms of the bits. And so it completely undercuts the message of Unicode, which is that you don't need to know anything about how you turn number 21C or 80-20 into a set of bits on the disk. And it turns out that 21C doesn't have anything to do with, if you take the hexadecimal digits, write them out as bits, doesn't have anything to do with the bits that are used in the most standard encodings to represent the apostrophe. I mean, to make things worse, it turns out that the representation for A does line up with the bits that actually correspond to A in the most familiar representations. It's like the typical ASCII encoding in terms of bits. But by referring to code points and using hexadecimal to provide sequence numbers when people try and look them up in the table, the guys who developed Unicode, which was a brilliant move in many ways, they created a huge impediment to understanding what's going on. And it's really very simple, which is just take all the characters in the world, put them in a sequence. Anytime you want to refer to it in code, just refer to the sequence number, and you're done. And somebody else gets paid to figure out how the sequence numbers get stored as bits, and nobody in this room will ever have to know anything about that. So the people who tried to explain their insights about Unicode did a terrible job of naming. They shouldn't have referred to code points, and they should have just used something simple like symbol or character to refer to the thing, and then a thing can have a sequence number. I mean, it may sound like I'm just like nitpicking here, but there's an enormous amount of confusion about Unicode, which is unnecessary. And with a slightly better choice of names, a little bit better explanation, we could avoid a huge amount of wasted time. And I think this is a case where the people who were trying to get Unicode adopted wanted everybody to understand. So I don't think it was lack of incentive, but I think they just didn't get the feedback. They should have been running experiments, presenting different names, different texts to people and saying, okay, do you get it? You see what's going on here? Let's, let me just see. So to just be clear, Unicode is an enormous step forward, but people who are not deeply involved in the development of it are much too confused about it. We could explain it better. We need to insist on better coding of the description of how they're encoding things like symbols. Okay, now what I want to do next is move towards a little bit of discussion about policies that might matter for, say, at the private level of things organizations might do, and then also public policy. To do that, let me go back to my picture. So we got stuff in neurons, stuff that's codified, copies or reproductions of that, and then stuff that gets back to neurons. Here's my kind of quick history of the human race. There was the Pleistocene, and that was boring. Then there were books in libraries, and then cool stuff starts to happen. Then there were docs on drives, and this was a huge disappointment. This didn't turn out so well. But then after that, we had content management systems. And I'll explain in a minute why docs on drives were so disappointing. Content management systems produced blogging. You know, a lot of blogging is summarized by this cartoon I like, where a dog is saying to another dog, yeah, I decided to stop blogging and just go back to pointless, ceaseless barking. But the content management system, you know, like WordPress and so forth, which is now, you know, pretty much out-of-date technology, provided one huge step forward, which was Wikipedia. Because all of a sudden with Wikipedia, you start to see codified knowledge that evolves over time. When somebody puts up an explanation of the Pythagorean theorem, somebody else can come back and look at everything about how they presented that explanation and edit it, including edit the math, edit the figures, edit anything there, and then make an improvement so that you've got knowledge which is living. The problem with the docs on drives is you put stuff into something like a PDF, and it's like putting a bullet through the head of the knowledge that went into writing that document. There's a picture, like a ping image, a ping or a GIF image, and you have no idea what were the data, what was the data processing that led to that image. And let me tell you, at the bank, you can't find out either. And what you're told, oh yeah, no, there's an Excel sheet on a drive, I'll get it for you. Yeah. So the problem with the Wikipedia solution, though, is it's totally centralized. There's one website. They're going to make one decision about, for example, how they present math, and then everybody's got to live with that. That's not a viable way forward for sharing knowledge. But the thing that I think is emerging now is, what you can see is something like distributed repositories of knowledge that can be copied, but are like Wikipedia in the sense that anybody can build on anything that came before. So now to think about this world, we need to bring in the machine. And once you've got codified information, the machine can do something with it and then, ultimately change its presentation, for example, as it goes back to another person who looks at it. So what we're looking at now are these dual readable files or collections of files where people can read them, to edit them, to improve them, but the machine can read them as well. And so these dual readable files, I think, present an enormous change relative to just, something like Gutenberg. Search, of course, is one obvious example where we've used the machine to help us manage all of this codified information. Things like typesetting, the presentation of the information, or the creation of the figures are another illustration. But one of the challenges we face is how to make sure that that doesn't end up like dead data with docs on drives, how we keep it alive. Now, what I'm going to try to do is show you this was something I was writing about test scores. It's the test scores on a particular test. I think it was the Iowa test of ITEF. I don't remember what the acronym stands for, but this could be a like an image in a PDF, and it would be dead. Nobody would know how to interpret it. Nobody would know how to check what I did. But moreover, somebody who says, oh, that's cool. You got the standard deviations on the horizontal axis. How did you do that? Let me just copy that because I could use that idea too. If it's a PDF, it's hopeless. What you're looking at is something called a Jupyter notebook, which is something that could host code and talk to backends and process the code. So the same document has all the code that I use to produce that figure, including both the overlaid smooth curve, the bars, but even, I hope it's all there. Yep, even the line you need to change the tick marks and the scale. And it's a long document, but if you scale to the right place in it, you can actually find the raw data too. So this is a document that could exist on a web server. It could be presented in this notebook kind of form that takes special software to present it to the user. It could also be presented as a web page, but the web page could allow somebody to click through, get the code, get the numbers, and this has attracted quite a bit of attention from academics because we're worried about auditing and catching fraud and misuse of numbers and data. But I think the more important reason to do this is because you can get cumulative learning about something like test scores, but also how can we label axes in ways that are meaningful? How can we use colors that are meaningful? So the one bit of private advice I would offer is start to think about in any organization you've got a rule where you don't let anybody store anything in a PDF or a PNG or a JPEG. You might have satellite imagery or photos, set those aside. But any generated image, any document you're presenting to somebody, don't let anybody store the PDFs or the images anymore. Because when somebody like me looks at the document, I want to run all the code to generate all the images, to do the typesetting, to produce the whole thing. Then I can check what's behind it, but I can also learn from it and pick up things like how to better present information to other people. So this, I think, and then think about this possibility of if all this information is available in some kind of a repository that's like a code repository, like Git, somebody can then just clone the whole repository. They can go build on it, do their own kind of thing. So this is the way knowledge should be codified going forward. And it should have a web, like an HTML representation, mainly because search is so geared to HTML. But users could be able to look at it in typeset form as well. The other thing I would recommend is that everybody start paying attention to this empirical question about, are people understanding the things we're giving them? If you actually want people to understand what you're giving them, you presumably want to know if they're understanding it and then change it to improve it. And just rest assured that there's an infinite number of improvements you can make. You just don't know exactly what they are. But cumulatively over time, these things should get better. Like the explanation of Unicode should get better. If you don't want people to understand what you're giving them, then you should think at least a little bit about the potential liability exposure at some point when a court finally says, yeah, that 16,000 word click-through license, what percentage of your users who click through that actually know what's in that? And if nobody who clicks through, or 0.01% of the people who click through actually know what's in it, at some point the courts are going to say, that wasn't disclosure that we're going to enforce. That wasn't an agreement that we're going to enforce. So from a defensive perspective, I think you need to think about, are we presenting information that we're supposed to present, that we say we're presenting to people in a way where they actually, if we go out and observe it, if they actually understand it. Now, at a public policy level, there's obviously a policy dimension to this, because anytime we mandate disclosure, we should actually be testing to see, is that disclosure effective? There's some other sort of oddball dimensions to this, though, that I think could be very important. The details of how you encode the characters in the scripts of the languages of the world in a way that developers can use was incredibly important. That Unicode is an enormously important public good that everybody can rely on. Let me describe to you another one. If I can. Get back here. So just bear with me for a second. This sounds like I'm crazy, but think about the spelling, the orthography of words in English. Okay, so we talked about glyph. Why does it have to be glyph with a PH? But much worse, think about something like betting. You've got bet and betting, but room and rooming. These rules about double consonants actually give enormous trouble to people who are trying to learn English spelling. So learning to read, learning to write in English. And the consequences of this could be non-trivial. There's one paper that suggests that the difference between Italian orthography versus English orthography means a difference between 10% of people who are going to end up being functionally illiterate and 5% of people who are going to be functionally illiterate. They all have this condition that we describe as dyslexia, but with a better orthography, it doesn't actually keep the 5% in Italy from failing to learn to read, whereas in people who are exposed to English, they do. Now, if this were just a matter for those of us who already speak English, so who cares? But if English is going to become the language of commerce, business, technology for the entire world, if we could change English spelling, just rationalize English spelling a little bit, and bring 5%. So 5% of 10 billion, if I'm doing my math right, is 500 million people. So it's like 500 million people who are either brought into the system or just left out. Those are pretty big stakes. Now there's good evidence that English spelling slows people down in terms of learning to read. So on average, we know there's a problem with English spelling. The thing about this evidence about dyslexia is that it also has an inequality dimension. It's not just that everybody is harmed a little bit by having to struggle with English spelling. There's some people whose whole lives are going to be harmed by this. So just as some group of people got together and figured out Unicode, there's more proposed rationalizations of English spelling than you can shake a stick at. So the only problem in this is trying to come up with some way to pick one of them. But I think it's actually an entirely doable kind of thing, and something where some organization that cares about the future and cares about the world should actually think about addressing this. If you want, I could elaborate on this a little bit, because I think there's some neat opportunities to use AI as a way to kind of model how people just use how machines learn to read and speak, and use that as a model for kids, and then use that as a way to test a whole bunch of different spelling systems and get the right trade-off between stick as close as you can to the existing one, but still make it much easier to read. And of course, it'd be perfectly doable in digital world to have different people reading different orthographies for English words. The translation would be trivial. To go back to the higher level, this problem of badly coded explanations, badly coded information, not only is it inefficient because we fail to use what's known about, say, cryptography, but it also provides cover for people who want to provide information which is not true. And so we need to focus on clarity and insist on precision and clarity, especially in the use of math and code, which can be, as we all know, they can be used very effectively to trick people. You can use, defaults to get all kinds of things that people don't understand. You can use math to confuse people. These are powerful tools, but they can be easily misused. If we care about truth and some social mechanisms that get us to truth, we need to insist on the clarity that lets us evaluate whether an assertion is actually true or false. I said I would come back at the end to the article about cryptography. Let me just show you the kind of the punchline. They don't cite it in the abstract, but when they looked at the cases of people who had results that seemed to work but actually were insecure, most of them were cases where somebody did a Google search or went to Stack Exchange and looked at the most popular option, the one that shows up at the top, and just copied and pasted the code from there. So, so there were lots of uses of DES, an insecure profile, and an insecure coding encryption system, and many other instances where what people were doing was they wanted documentation in the form of an example that they could actually copy and use, but the examples that they found were in many cases just wrong, just insecure. So we have a system of science which isn't perfect, but it has this feature that over time it tends to weed out the wrong answers and move towards the right answers. Things like Stack Exchange or Stack Overflow, or just blogging and how many hits you get, these don't work as well as the system of science. And perhaps because of competition from them, perhaps for other reasons, I think science and expertise and the whole kind of legacy of the scientific revolution and the Enlightenment is under siege these days. So precision and clarity in the assertions we make, and then the evaluation of those assertions, and the winnowing out of the ones that are right, and the retention of those, and the dismissal of the ones that are wrong. This is really essential towards this process of moving society forward. And I I used to be the most optimistic economist I knew. Oh yeah, growth, it's just gonna keep going faster and faster. I may just be getting old, but I feel like concepts like truth and expertise and science are under siege. And I don't think the simple political stories capture the whole dynamic here. The really troubling case for me is the anti-vax movement, which was triggered by an academic who just cheated, published a paper that was just completely bogus and false, and then a journal which kind of lent cover for this. But science did what it does, and it pretty quickly dismissed this paper as a fraud, and the guy was actually basically pressed out of professional practice. But this thing has just taken off and has had a life of its own. There was a recent email sent out in England to pet owners saying, your pet can't get autism, your pet can't get Alzheimer's, because people weren't taking their pets to get vaccines for things that protected their dogs. So we need to understand, why is it that notions that are just plain wrong are thriving, why expertise is under threat. And the one part that I'm certain of is that precision and clarity in our communication is going to help us defend the things we want to defend. Thank you.
To save on time, why don't the next panel come up while we do some questions? And actually, we'll start with this because we had some good questions coming in here. So one of the questions with the most votes was, how do you create incentives for clear communication and policy, since the incentives often favor obfuscation?
Well, I think across the board, feedback is the first. Feedback and measurement is the first thing to bring in. So just test to see, is the putative recipient of this information able to make sense of it? And just absolutely rule out of bounds, blame the user, blame the reader. If the reader doesn't understand, it's the writer's fault. Just no question. So see if people understand. If they don't understand, it's the writer's fault. Make that visible to everybody. Now, if you're talking about regulatory compliance, you might use evidence about comprehension to impose some sanctions. But I think in organizations, just surfacing the information would go a long way towards doing better.
And the second one, and from David Young, you get special credit because he put in his name rather than just being anonymous. Okay. How do you effectively communicate something that people don't really care about, like what seems to be privacy policies?
Yeah. I think people do care about privacy, and I think we can communicate it in a way that makes them care about it more. But they got to understand it, and it can't be like a 16,000-word click-through license. So, and I know it's a challenge. I mean, not a lot of people won't care, but some people will, and journalists will write about it. More clarity in this issue, I think, would go a long way. And I had the privacy panel in mind when I was thinking about these problems about kind of this growing tolerance for obfuscation and kind of dishonesty by effective omission that I think everybody should be worried about.
I think there are actually a couple that kind of boil down to path dependency. You're talking about making changes that you might have 500 million more people who can learn English, but how are you ever going to change?
Oh, yeah. Yeah, no, I've thought pretty in quite a bit of detail about this. The first thing is, you're not going to change how any of us spell English words. So, but you don't have to. What you want to do is take all the people who are going to learn English, most of them as a second language for the first time. There's no reason why they need to learn to spell the same way we do. And if they get an email from us, they can just turn on the stupid spelling kind of, translator into rationalized spelling, and, they can even read the emails we send them.
Okay, I think we should probably.
Good, thanks.
All right, thanks a lot, Paul. Appreciate it.